Okay, so we're gonna start into a small little debug application here. We're going to do a basic command line tool, a Mac-based application. This will be our only Mac application in this course. And then from there, we're going to get into iOS applications all the way through after this. But the purpose of this is to be able to sort of get comfortable with the debugger, the environment itself, and just see some command line stuff as it is as well. And so what we're going to do is, what'll happen is it'll remember the last thing you did. Now, first off, when you launch Xcode, you should see a small rectangle that says Welcome to Xcode, and you should see something on the right-hand side that lists out your previous projects, and then on the left-hand side you'll see New Project or Open Project, those options there. So if you go New Project, it'll pop up a window like this, and you'll see that you have iOS. You can make an iOS application. You can make a watchOS application, a tvOS application as well, so a TV app, or an OS X application. And what it ends up doing is that every time you do new application, or new project rather, it's going to remember and show you the previous thing you did. So for me, it was an iOS app that I had done previously, and that's why it started off at iOS. What we're going to do here for our only time is that we're going to choose OS X application, and we're going to choose command line tool. So just a very basic hello world is what we're going to do here. All right, so we're going to do OS X, application, and command line tool. And then we'll hit next. And we'll give it a name. So we call this one W3 debug. And the purpose of this is that it will allow us to give a name to our application, but also we'll see here organization name. We're going to set up our organization identifier and our bundle identifier. So you choose whatever you want for organization name, for organization identifier, and bundle identifier, because it doesn't matter for us. We're just creating a simple little application here. But if you were publishing this application to the App Store, these things matter. So in particular, organization identifier matters because you want to have a different organization identifier from everybody else in the world. Okay, because if you have the same one, then a lot of question marks get raised, especially because of the bundle identifier. The bundle identifier is always unique to every application in the world, and so you have to make sure that yours is different. And if there's ever an application that comes up with the same name, then Apple will reject that app, and so it doesn't like that. And so that because it's able to differentiate between which app is doing what because of this bundle identifier. So typically the bundle identifier is a composition of your organization identifier plus your project name or your product name, and those joined together become your bundle identifier. After that, the language, we can choose Objective-C, Swift, C++, and C. We'll stick to Objective-C for this, and then we'll hit next. And then we'll give it a home. I'll just save it here. I'll hit create, but you can choose wherever you want to save your project to. Okay, and then once it's generated the project, you'll notice that it starts off by placing you in the project settings. And when you look at the project settings, you'll see that the look and feel of it is very similar to what you will see in an iOS application. If I click on the project itself, W3 debug, it'll tell me the deployment targets with different versions of OS X. In iOS, you'll have the option of different versions of iOS, different configurations, build settings, so anything that you want to configure here, you can for the build. But you'll see here that we start off with one file, main.m. And even the iOS applications all have a simple main like this, and then they tell it to launch an iOS app. That's typically what they do. And when we look at our iOS app, we'll look at what main looks like in that application. But here, what we see is that we are importing foundation.h. So like in C, you include stdio.h, so it has the core constructs of the language for foundation for Objective-C. And then you see int main, and you see some arguments inside the round brackets. Now, if I launch the terminal, and I bring it over here, and I want to show some commands. So let's say I say ls, and I say ls-al. There's a difference in how it looks, right? So what I'm trying to point out here is that we'll have some arguments that go along with our command. So what we're going to build here is a command called ls, for example, and then we'll have some arguments that can go along with it, like -al. Now the -al, when we run our application, will actually appear here under this argument, argv. And because we can have multiple arguments, we could have ls, and then we could have ls-a, ls-a-l. We have multiple arguments there, right? And so because this is an array, you would see -a, then you'd also see -l. So you can have an array of different commands that get passed into the command, right? And the number of commands that are sent will be told to us through this variable argc. It's like arg count, basically, is what it would stand for. And argv would be the actual variables or the actual values of the arguments that are passed in. So that's the purpose of having argc and argv here, because it's our opportunity to actually pass in different arguments from the command line. Now you may have noticed when you were taking Java that you had public static void main string args. So that string args is exactly the same thing. You could pass in commands into main, take them in, and then choose what you want to do with them. Like you can say if your argument was -v, do this. Else if your argument was -a, do this other thing. Else if, right? You can have a whole bunch of if statements and to do different things to your program and output different things to your user based on what's passed in. That's the whole purpose of what's behind the round brackets that you've seen in Java and what you're seeing here. So having said that, I'll take this away. We'll see this. We're going to see this keyword called auto release pool, and we'll get into this: what auto release is, what release is, what the pool is, like all these different things. We'll get into these later on. But for now, we'll just assume we'll leave it there. We will pretend it's not there and it doesn't exist, but we'll just continue on. And we have here the line nslog hello world. And so what we're seeing here is that nslog, like we said before, is kind of like a printf or a system out println or system out printf that we've seen in Java that allows us to print stuff to the screen. And so if I make my console visible and I run this, first off, my options to run it are very limited. I just have my Mac to run it off of. If I hit run or hit the play button, I'll see my progress up here. Right? I'll see build succeeded down here. And as it runs, it's going to simply say hello world down here in this corner. Eventually. There we go. So it says hello world. It gives us a date timestamp for running the word hello world. Now, what we could do is we could take a step further. We could put this into a for loop. So I could say like for int I equals 0, I is less than 3, I plus plus. Right? And I could run this, and it'll just print out hello world 3 times, right? Nothing special. It's just a simple for loop, and it's just going to print out hello world 3 times, right? With different date and timestamps. Right? So you can kind of see it's down to the millisecond here, where it's telling me exactly when it was printed. Again, nslog, these statements, they're not useful to an end user, but they're useful to you as a developer to be able to do things like check to see if you connected to a database, be able to successfully query that database, to get the proper data back. One of the uses I had for it one time was I was retrieving stuff from a database, I converted it to JSON, and I got the JSON back here, and iOS has a built-in Json Parser. So it would parse the JSON, and there was nothing wrong with the JSON. It looked perfectly fine, but it would return nothing back. It would complain that it's like bad JSON and that I had to go and investigate why. And I eventually found out that it was sending me back an extra character at the end, some odd little closing square bracket, and so that I could not tell, like until I carefully looked at it by using an nslog statement, I was able to print out the entire JSON that was sent back to me, and I would see, oh, there's this weird square bracket at the end of it that I would never notice in a million years. So I had to do some string manipulation and just drop that silly little closing bracket, and that allowed me to finally display my JSON. So instances like that, you'll find nslog to be very convenient for displaying stuff to you and to figure out and to help you with debugging and figure out what's going on when things don't work. right, so getting back to it, suppose we wanted to put this inside a function. And so remember, this is C code now. We're doing a little bit of Objective-C here, but it's predominantly C code, even though it has a .m file extension, because we can mix C and Objective-C together easily. So maybe I'll make a function, we'll say void do nslog, for example. And notice that I'm using C functionality here, so I'm not putting a dash or a plus right next to my method name. Instead, I'm using just the method name and a return type. And I could move nslog down here and maybe call it do nslog up here in the for loop. And watch it complain. Right? So if we look at the error message here by clicking on the stop sign here, it'll say conflicting types for do nslog. If I look at the warning here, so warnings are not necessarily errors. You'll still be able to run your code with warnings. But if you see an error message, it'll stop you from building and running. So we see here implicit declaration of function do nslog. The nice thing about warnings is that warnings actually can tell you more about the problems in your code than error messages will. See, the error message doesn't tell me anything. It just tells me conflicting types. What does that mean, conflicting types, right? But then when I look at the warning, it says implicit declaration of function do nslog. This, when you translate it, is essentially saying, hey, we've got a method or a function called do nslog here, but I don't know what it does. I don't know what it means. Right? It's telling me here that you've declared this function, but I can't find it. I can't see it. Right? So, but because it's C that we're dealing with here, we've declared do nslog down here. The problem is that we have to either declare a function prototype up here because this is the language C, or we have to move this function above. And I'll just make it easier and move it above. Or the third option is to put into a separate file and import that header file here. But now that I've moved the function above, the error message has gone away. And if I run it again, it's going to do the exact same thing. So just hello world 3 times. Right? And I could, as you will probably figure out, you can declare variables as you see fit. So like int x is equal to 3, or double z is equal to 2.4. Let's take it a step further. Let's create another function up here called print me. So we'll say void print me. And I'm going to move do nslog up here. I'm going to call print me over here. Right? So now we have 3 functions. We have print me, we have do nslog, and we have int main. Right? And so you're probably thinking, well, this is a very simple piece of code. Where am I going with this? And we're going to see why I'm doing this right now. But we have 3 functions. The purpose of these 3 functions, and we have some variables here that I declare, but I don't even use, some very basic variables, an int and a double. Now we're going to see why I've actually created this here. Because I'm going to stick a breakpoint in. And the whole purpose here is to illustrate breakpoints and debugging to you right now. So the way we stick a breakpoint is just to click on the little gray area over here. If you've got line numbers, great. You can click on the line number, and it'll put a blue arrow over here pointing to the line of code it's going to stop at. So I could have multiple breakpoints, and also if I want to get rid of it, just click on it again. It grays it out. If I want to delete it completely, right-click, delete breakpoint. Okay? But I'm going to put one right here, and I'm going to run my program again. So I'm going to hit the play button. And this time, it'll run, and it will stop right here. The way I know that it stopped is because I have a green arrow, and I have a green line of code. Quite often, you will run an app, and you'll be clicking on your simulator, and it won't do anything. And you'll be wondering why, like what's going on? Like it's broken. Like I have an error somewhere and I can't figure out that error. When in essence you don't have an error, you put a breakpoint in by accident, you ran it, and the program stopped. It did what it's supposed to do, and you'll find that, oh wait, I accidentally put this breakpoint here. I didn't even know I was stopped. And so the trick is to continue on with the application or to delete the breakpoint and continue on, whichever what you want to do. But what we're going to do here is we're going to pause the program here, and we'll look down here at the bottom here, and we'll see argc is 1, argv is, really there's nothing here, right? So maybe just a slash, but that's about it. I is declared, so I is 0, right? And then we'll see that there's different buttons here that we can play with. So this is the continue button. This little play pause button here is the continue button, so I can continue on. And it'll just finish the program. It'll do my hello worlds 3 times. So I'll just run it again, and we'll look at the other buttons. So we have continue, we have step over, and we have step in, and we have step out. The purpose of step over is to say, okay, we'll look at the line of code. Yeah, we're happy with the line of code. Let's go to the next line of code, right? Like that. Step in says, oh, I'm at a function. I want to go inside this function. I want to continue on line by line inside the function. So I'll click on step in, and it puts me inside the function I'm going to jump to. And step out essentially is, I'm done with this function. I want to leave this function. I will return back to where I was called. So those are the 3 main ones that you care about. Step over, step in, and step out. In NetBeans, you may have seen other ones as well, but these are the main 3 that you would ever care about. In fact, step out, not as common as step in and step over. I think those are the 2 most common ones you'll ever care about in any debugger you use. So essentially, what we're going to do here is I'm going to step over and step back in. And notice that my options here changed. So it says int x equals 3. And if I step over, I have double y is equal to 2.4 or 2.3999999. Right? So depending on the architecture you're using, it may round up to 2.4, or it may just keep it at 2.9999, depending on the bits, essentially in the registers. So it's all about how the computer, the CPU, handles these things. But essentially, you'll see your variables here, and you can continue to step through, right? And so on. And so essentially, there you have your entire debug approach here. Now, let's take this a step further, and let's learn how to add an object to this. So we want to add something to the project. And actually, before we even do that, let's look at this option up here. This is the Breakpoints Inspector, the Breakpoints Navigator. And you'll see here, if you expand this, you'll have all your files listed here. And you'll see that I only have 1 breakpoint on line 27. If I add another breakpoint, let's say I add one there, I'll also add another one, right? I'm going to add a third one here, right? And I can delete them. So I can delete breakpoint, and I can jump between breakpoints. So if I want to jump to a particular line of code based on a breakpoint, I can just click on that breakpoint and just jump right there. So here's your Breakpoint Navigator to help you navigate different breakpoints as well. Now, like I was trying to get into, we're going to add a new object. So if I right-click on this folder, W3Debug, and I say New File, you'll see here that it'll open up to the last thing you tried to add to the project, right? So in this case, OSX, source, Cocoa class is what we care about. We could do Objective-C file, but it's just an M file. We could do an H file, or header file. Just an H file is what we return. Just a C file, just a C++ file, just a Swift file. But what we care about is a Cocoa class, because it'll generate the H and the M file for us automatically at the same time. So that's why we're doing Cocoa class. So again, Cocoa, Objective-C, same name essentially is what we have here. And so why we're doing Cocoa classes again is to have both C and H file generated at once. So if we hit next, we'll give this class a name, and I'm going to call it prime. And it'll be a subclass of NSObject. You'll have a ton of objects to subclass it from, but we're going to stick to NSObject. And over the course of the term, we'll be subclassing other things like UI view controller or UI table view cell and so on. We're going to subclass other objects, but for now we'll just subclass NSObject. And like in the Java world, the most highest object in Java was object. And here in Objective-C, it's NSObject. when we add this file and we give it a home, so we're going to give it a home in this local directory, which is good enough for me, you'll see that it auto-generates the H and the M file for me. If I start off with the header file, it's importing foundation.h. So like in C, it would have imported stdio.h, the typical C construct. So we're importing this typical Objective-C constructs that we need for the language. And then we're getting right into defining the interface for this object. Now, unlike Java, where we had just one file to define the class, here in Objective-C we have two files to define the class. And the purpose of the H file is to define the structure of this class, whereas the purpose of the M file is to define the implementation of the class. So implementing the methods that we want to have inside the class predominantly. So if we start off with the header file, we're going to say interface prime extends, so the colon represents extends, and then ns object. So unlike Java, where the parent object was object, we never extended object, even though by default it was actually doing that. So in Java, it was implied. We always extended object. So we would say like public class prime extends object, but we never said extends object because by default it would do it anyway for us. But here in Objective-C, we have to. We have to tell it what we're extending, and if we have nothing to extend, it's always ns object. That's the highest most class. So we're saying interface prime extends ns object. And then what we're going to do now is we're going to define our variable. And in this case, it'll just be one variable. It'll be long prime. And as you guess, it'll just hold a prime number. Now, in previous implementations of the exercise we've done, we have simply used the commands property and synthesize to define our get and our set, and it really saved us time. And it's great to be able to do that. But here in this example, we're going to do the long-winded approach for defining our get and set. It's only one variable anyway. So we're going to define a get. So we'll say return type is long. And we'll say get prime. And then we'll do our set. We'll say void set prime, passing in a long n. Now I'm breaking away from the way gets are defined in Objective-C into more of a Javaism, meaning that for get prime in Objective-C it's typically just prime. So in Objective-C, the name of the variable always matches the method name for the get. But I'm going to go with get prime just because we're all Java developers here and we're used to Java and we're just making our jump into Objective-C. So I'll keep to the old Java expression for now, and then eventually you'll see that we'll be getting heavily into Objective-C. So we have two methods, get prime and set prime. And we're going to define these in our M file, what they exactly do. So we're done with the header file for now. We define the structure of the class, so it has one variable called prime of type long, and it has a get and it has a set. And so I'll do a Command S to save. Now I'll switch over to M, the M file, so prime.m. And now I'm going to actually define the two methods. So I'll say long get prime and just return prime. And then I'll say void set prime, and like how it's auto-completing, and say prime equals n. And that's it for this object. So we have a get and we have a set. So we define that in the header file, we define the structure of it by saying we have a variable, we have two methods here. And in the M file, we define the actual methods and what they are and what they're going to do. So now we have our prime object. The next step is to actually use that prime object. So what we're going to do is we're going to switch over to main.m. I'm going to delete the breakpoints. And if I want to use this header file, I'm going to say import prime.h. And notice that the way I'm encapsulating the name of the file is different from the line above. So with foundation.h, we're using angle brackets. For prime.h, we're using double quotes. And this is a carryover from C. So in C, the reason we used angle brackets was because we were defining a system file, or we were including a system file. So like stdio.h, or in this case, foundation.h. But basically anything built in to Objective-C is what we are going to use angle brackets for. So foundation.h, uikit.h, and so on. Prime.h is a file we created ourselves, so it's local to us. So whenever anything's local to us, we use double quotes. So that's the main difference, is that you're either going to use double quotes for something you created, or you can use angle brackets for something that was given to you, essentially. So here we've included or imported prime.h, and now we want to instantiate an object. And I've held off on instantiating in our previous exercises because there's a reason for it. It's a bit of a longer step to instantiating an object here in Objective-C than it is in Java. So in Java, we would have been accustomed to saying like prime p is equal to new prime. This is what you've been accustomed to seeing. One line of code, simple, straightforward. We would have put stuff between the round brackets and would have instantiated our object. Well, in Objective-C, things are different. So what we see here is we see two things that are going on actually. We see the word new, right? And we see that we have these round brackets. Okay? In Java, we always thought of this as just one operation going on, when it's actually really two operations. The word new signifies that we are asking for memory to be allocated for this object. So we're going to RAM and saying, hey RAM, give me some space here for this new instantiated object. And then these round brackets are basically saying, hey, I've got this constructor, I want to run this constructor, right? So no arguments means we're running the default constructor, and anything inside the round brackets meant we had a customized constructor we were running, right? So there's actually two operations going on here. There's asking for RAM, allocating memory essentially, and there's running the constructor. So in Objective-C, we outright do those things as two separate steps. So our first step is to ask for memory. So we're going to go into RAM and say, hey, we have this object called prime. Let's allocate some memory. So I'm going to say prime alloc. In C, you saw malloc. Right? You saw malloc, meaning malloc some memory for me. But here we're using alloc in Objective-C. So this is the first step. This is get some memory. And let's save this variable inside memory. Even our ints, our floats, our doubles always occupy RAM. They always occupy RAM. But it's more seamless there because it's just, hey, I got an int. Let's stick it in RAM. Right? That is very simple that way. We didn't even see it happening. It just did. But here, we're actually requesting memory. Now that's the first step, request memory. Second step, let's run the constructor. So I'm going to add a second set of square brackets and run init. So remember, init is my constructor. So we had like init with data, and last time around we built some classes where we would run our own. We built a default constructor and we built a customized constructor that passed in arguments. So we might have said here, if we had used any of those other constructors, we might have said like init with data, and then had like arguments passed in, right? So we could have done that. But here we just have a basic default constructor that we are calling. So now you are seeing two steps involved, and we're still seeing one line, but we're seeing two steps here. It's actually more outright here, right? They physically are telling you where there's two steps going on here. Allocate memory, return that memory, and then fish it into the constructor. What's being returned here is a memory address, which we don't really see, but that's what's going on, is that this line of code is actually returning a memory address. And that memory address is being thrown at init to say, hey, do all your initializations, send it off to this memory address to save your stuff. That's exactly what's going on here. It also happens in Java. We don't see it. Like we just say new and the object name, and that's it. So we have our object. We've instantiated it, and we're going to start instantiating stuff left, right, and center. So you're going to see this more and more and more and more. So if it still feels a bit intimidating, don't worry, you're going to get used to this. So our first step is let's set the value to a number. So we'll say like p set prime. Let's set it to number 13. And let's print it back to the user. So we'll say like nslog, and we'll say the value is, and we'll say like %d, and we'll say p get prime. Now it's giving me a warning, not necessarily an error, but a warning here. So I could actually still run this. It probably will still run okay, except when you get to larger numbers. But let's see what the warning says. So it says here, format specifies type int, but argument has type long, which essentially is saying, hey, you got a long, you got an int, you're supposed to be saying long here. And it's giving me a suggestion. It says, hey, let's switch this from %d to %ld. So I hit enter, it'll switch it over. So you see that Xcode is trying to help you out here with some suggestions on how to fix your code. And you're going to see that more and more and more, is that Xcode will try and suggest things. They might be cryptic at first because they may not make sense to you, but over time, as you get used to this language and get used to Xcode, you'll see that things will start making sense really quick. So now if we run this, and it did our hello worlds 3 times, so I won't even worry about that, but it just says the value is 13 and it ends the program. So what we're seeing here is that we've instantiated an object, we've saved its value, we've got its value back and printed it back to the screen. So you've seen here is an example of creating a project and then creating some functions in C, working with it, working with Xcode, working with the debugger, creating breakpoints, stepping through those breakpoints, then creating a class, and then instantiating that class, and then getting and setting a value from that class.